Hello, good evening, class. How are we all doing? I hope we are doing good. Hope we are doing fine. Please excuse my voice. I have a bit of catarrh and a kind of cold, so hopefully I'm clear enough. All right, so let's go. Let's get into it. Okay, let's go back. So today we are going to be learning understanding IP addresses, understanding ports, and understanding the network protocols, right? So let's get to it. All right, what's our objective? So the first objective is understanding the basic concept of IP addresses, ports, and network protocol, explain the different types of IP addresses and ports, and describe the different types of network protocol. So this is basically what we are going to be learning today. Alright, so let's start with IP addresses. So an IP address, that is internet protocol, most people just call it IP address, is a unique numerical label assigned to each device connected to a computer network that uses the internet protocol for communication. So basically, what is IP address? What's an IP address? An IP address are unique numerical labels assigned to a device. Once you connect to a network, either your local network or you are connecting to the internet, right, you are assigned an IP address. So that IP address is a unique identifier. So it's numerical, like it's numerical or alphanumerical depending on the type of IP address, right? But it's unique to you, it's unique to your particular laptop or your particular device that you are connecting to the internet. So what are the functions? Like why do we need to assign IP address? Number one, for host identification. An IP address uniquely identifies a device, that is a computer, a smartphone, laptops, tablets, a server on a network. So it's similar to postal address, allowing data to be sent to the correct destination. So host identification, basically it means that for you to tell which device is on a particular network performing a particular activity. Let's say for example in a class of 5 students, they connect to the router, right? The router assigns them an IP address, each of them a unique IP address. Why is that? So that when a particular system is performing a particular activity, the router can be able to tell that, okay, this activity, this person that is going to this site is laptop A. The person that is going to Netflix and chill site is laptop C. You understand? So the goal is to identify the host, to identify the device on the network, to know what activity is performed by who in a network. Den the next point is for location addressing. So the way it is that how do like when devices are connected on a network or devices are connected to a router and they want to send information to one another, the way they do that is by using the IP addresses. So what happens is that a data packet, when let's say let's use laptop A now and laptop D. So laptop A wants to send a music file to laptop D. So what will happen is that once laptop A send this file over the data packet contains the IP address of laptop A and the IP address of laptop D, so that it can tell who is actually going to send um data packet to, so that it's not just broadcasting to everybody in that same network, but rather it's going to send to a particular person. So let's read what we have. So IP addresses also play a role in routing data across network. Routers use IP address to determine where to send the data packets to and reach their intended destination. Awesome. So the next step is the type of IP addresses. So there are two major type of IP addresses that we have. We have IPv4 and then we have IPv6. So Internet Protocol version 4, which is IPv4, is composed of 32 bits, which are typically represented by as four sets of numbers between 0 to 255 separated by a period, like this example that we have here. So it's a 32 bit that is composed of 32 bits, and each of these places here can range from 0 to 255, 0 to 255, 0 to 255, 0 to 255. You get, so that is basically um how it is being addressed. And there are about 4.3 billion unique IP addresses. And over the years, it has been exhausted due to the rapid growth of the internet. So we have about 4.3 unique IP addresses, right? But come think about it, there are about 8 billion persons in this world. And let's say, okay, let's not say that everybody have access to the internet, but we can assume that at least 4 billion people should have access to the internet. And guess what? If we have 4 billion people having access to the internet, most people don't just have one devices. They either have their laptops and phones, their phones and tablets. Sure, something they sure always mix something together. So that is why right now the IPv4 addresses have been exhausted, and that's why we went over to IPv6, which is the Internet Protocol version 6. So the Internet Protocol version 6 is designed to overcome the limitations of IPv4, which consists of 128 bits and are typically represented as 8 group of hexadecimal numbers separated by columns. So what happened here is that IPv4 was 32 bits, but IPv6 is 128 bits, and IPv4 was represented in decimals, right? That's base 10. But IPv6 is represented in hexadecimals, which is base 16. The goal is just for expansion, right? So because of its IPv6 is making use of 128 bits, we have a wider pool of unique IP addresses to make use of, to like what do you call it now, to be able to accommodate the growth of the internet, you get, because almost everything are being assigned IP addresses. Your smart homes are assigned IP addresses now, because before televisions not connect to the internet, but now once the television can connect to the internet, it will be assigned an IP address. You understand? So anything that can connect to the internet will be assigned an IP address. You understand? So that is the reason why we're moving into IPv6 to be able to accommodate the large growth of the internet. Then let's talk about octets in IPv4. So octet refers to a group of 8 bits within an IPv4 address. IPv4 addresses are typically represented as 4 decimal numbers separated by a period. Each decimal number is an octet. So what is an octet? So an octet is basically, if you look at this IP address 192.168.1.1, this 192 is an octet, this 168 is an octet, this one is an octet, this one is an octet. So an octet just refers to a group of 8 bits within the IP address. And then we know that IP address consists of 32 bits as the last slide, right? So each of these octets is just 8 bits, and 8 bits in 4 places is what? That's 32 bits. Which so an IPv4 address consists of 32 bits, which are divided into 4 groups of 8 bits. Each octet can represent a decimal number between 0 and 255. We stated that before. So we're talking about digital representation now. To make IPv4 addresses more readable, more human readable, each 8-bit octet is converted into a decimal number. For example, an octet with a binary value of 00000100 equivalent to the decimal value of 4. So basically it's like binary conversion. So if you convert this now, this stuff, if you do your 2 raised to power 0, 2 raised to power 0, 1 times 2 raised to power 3, all those kind of stuff, right? 1 times 2 raised to power, this is 012, 1 times 2 raised to power 2, all those stuff, you'll be able to get your value as 4. So the goal is basically to just convert your 8 bits into what they call it, into decimal numbers. Basically, that's the goal, to convert 8 bits into decimal numbers. So that's it. So an example of an octet. So we're going to still use this one. So if you look at this one, we have 192.168.1.1. So 192 is the first octet, 168 is the second octet, 1 is the third octet, and the last one is the fifth octet. Excuse me. All right. So we are going into public versus private IP addresses. Now, IP addresses can be classified into two major parts. We have the public IP addresses and we have the private IP addresses. So public IP addresses, these are unique identifier sorry, these are used to identify devices on the open internet. They are assigned by the internet service providers and are globally unique. Public IP addresses are used by web servers and email servers and other devices that need to be accessible from everywhere on the internet. So public addresses are assigned by the internet service provider. So internet service providers are things like MTN, your Etisalat, your your internet service provider, your Spectrum and the rest. So that is public IP address. So they are being assigned and they are unique, right? They are unique globally because everybody wants to make use of these addresses. Like every device connected to the internet, like globally, has to have a unique IP address. You understand? So that's why it's public, right? Things like a web server, for example, now Google, now you can set Google's web server IP addresses. All these ones, they are unique because everybody everywhere wants to be able to access it and we don't want to keep on changing IP address, whereas the case is different for private IP addresses. So private IP addresses are used within local networks or such as your computer and your company's and like your organization. So the way it is that for private IP address in an organization now, when you come into the organization and you connect to the network, the router, right, will assign you a private IP address. You get, so you'll be assigned a private IP address, and this IP address is not going to be shared with the internet. It's unique to you within the organization. You understand? It's not going to be shared to the internet. But when you want to communicate to the internet, your IP address will be resolved to a public IP address that you can use to communicate to the internet. But in the organization where you are working, right, your own IP address is going to be unique to your system in the organization and that will not be shared to the general, like to the internet, basically to the global network that connects everybody. So I just hope this is clear enough. We can read about the public and private IP address one more time and get the feel of it. So subnetting. Subnetting is the process of dividing larger IP networks into smaller subnetworks or subnets. It is a fundamental concept in IP addressing, allowing organizations to efficiently manage and allocate IP addresses within their organization. So think of it this way, right? Let's say as an organization, you want to you have different departments basically. Let's say you have the marketing department, the financial department, the accounting department, the IT guys department, and you want that each of these departments, you want to subnet it, you want to segregate it, you want to say that okay, these IP addresses are for accounting people, these IP addresses are for marketing guys, these IP addresses are for the network guys, right? So this the way you can do this is through subnetting. So subnetting simply means you are dividing a larger network. Let's say you've purchased 10,000 IPs or you purchase like a block of IPs and you can divide them. You can divide, let's say 2,000 should go to the marketing department, 5,000 should go to the the networking guys and the IT guys and stuff like that. So basically subnetting helps you to just divide the IP addresses in a network. Now let's go deeper into private IP addresses. So private IP addresses are reserved for use within private networks and not routable over the internet. So you have to understand that private IP addresses, you cannot use them over the internet. It is unique to an organization. And so even if you try to go to a private IP address, it will not resolve to anything basically. So these are defined by several standards. The most commonly used ones being based on the Internet Assigned Number Authority. So there are these people called IANA, which ended up bringing up the standard for the private IP addresses. And there are three ranges. So there's range A, range B, and range C. So range A is class A rather. Class A private IP address ranges from 10.0.0.0 to 10.255.255.255, right? So basically we have a total of 16,777 16,777,216 different IP addresses within this block or within this class A, right? And so who are the people that makes use of class A IP addresses? They are large organizations, right? Large organizations, people like Microsoft and the rest. They are large organizations that and are flexible for subnetting into smaller network. So large organizations make use of this IP addresses because you have like 60 million addresses, and how many people do you want to employ? 60 million IP addresses. So there's this thing called CIDR mutation. You have to take note of it because this is how you usually represent the the private IP address in the network. So we have the class B private addresses. So the class B private IP address ranges from 172.16.0.0 to 172.31.255.255. So we have a total address of 1,048,576, and the class B private IP address are suitable for medium-sized networks. And we have the class C. So the class C ranges from 192.168.0.0 to 192.168.255.255, and it's about 65,536. So they are used for smaller networks. So these are like home offices, home or office network, share a small office network. So you need to take note something, and we need to take note about private IP addresses. These private IP addresses ranges are not globally unique and can be reused in different private organizations without causing conflict. But the way it is that, let's say you have organization A, organization B, organization D. They can make use of the same private IP addresses, right? And it won't cause conflict. Why is that? It's because the private IP addresses are not routable over the internet. You cannot paste a private IP address and expect it to resolve to a particular website, a particular server or something like that. When devices within a private network communicate with a public internet, a process called network address translation, that's NAT, is often used to map multiple private IP address to a single public IP address, allowing multiple devices to share a single public address. Excuse me please. Alright, so let me explain now. So let's say in an organization, right, we have about um let's say about 500 unique systems, 500 unique laptops and 500 unique devices basically, and all of them have their unique private IP address. Remember that private IP address is just unique inside the organization. You can't route it over the internet, right? So let's say for example now I am in this organization and I want to Google something, or I want to access a website. What would happen is that everybody in that network can communicate to the internet with a particular public IP address. So everybody is going to be routing through that public IP address. And if, for example, that I'm connecting to a web server, what the web server would see, what the web server network would see is not going to be my private IP address. No, it's going to see my organization's public IP address. I hope you guys are getting it. If you are not getting it, maybe you can watch the video again, or you can go on YouTube and just research about public and private IP address, and more explanation will be shared there. So using private IP address is essential for maintaining security and integrity of internal network, as it helps prevent IP address conflict and provide an additional layer of privacy and security by keeping the internal network hidden from the public internet. Exactly. So basically, the reason why we are using private IP address within organizations is for security purposes, so that your um the internet, the people on the internet don't have direct access to your internal network, basically, because every Dick, Tom, and Harry is on the internet, so you have to be careful, right? So, how IP addresses work? When you visit a website, your computer sends a request to the web server. The web server then sends a response back to your computer. In order for the web server to know where to send the response, it needs to know your computer's IP address. Do you get it? So let's say you go to your server, you say you are going to Google now and you search for how old is this particular person. For it to send you a response, that's not to happen within seconds, right? The the web server needs to know your computer IP address, and your computer IP address is assigned by your ISP. When you first connect to the internet, your ISP assigns your computer a public IP address. This IP address is used to identify your computer on the public network. Remember, it assigns you a public IP address. But however, when you connect to your home or your office network, your router assigns your computer a private IP address. So basically, look at it this way. Every device has two addresses, your private IP address and your public IP address, basically. So when you connect to a home router, when you connect to your SpectraNet, your MTN MiFi, everybody's connecting, you have a private IP address, right? But when you are communicating to the internet, what the internet sees or what a web server online sees will be your public IP address. Do you get? I hope this is clear enough. Alright, so let's move. So we are moving to the next one, which is ports in computer network. So a port is a virtual point where network communication starts and ends. Ports are essential for exchange between different devices or applications over a network. So you can think of ports as virtual doors or channels through which data enter and exit. So as the name implies, ports, what's a port? If you think about normal ports like ship ports and the rest, just know that things come in and go out, right? So just think of ports in a computer network as virtual ports or channels, virtual doors rather, or channels through which data can enter and exit. So what are the key things to note about ports? Number one, port numbers. Port numbers are identified by ports are identified by numbers ranging from 0 to 65535. So port numbers range between 0 to 65535, right? This number serves as an address for network services and application. So why it's assigned a number, because it makes it easier to identify, right? So it serves as an address for network services and application. So some well-known ports have assigned numbers, such as an example is port 80, which has to do with HTTP, which is web traffic, and port 22, which has to do with SSH, which is secure shell. So this HTTP and SSH are protocols and network protocols, which we are going to dive in on the next thing we're going to talk about basically. So the next thing is TCP versus UDP. So ports are categorized into two main categories, right? We have the TCP, which is the transmission control protocol, and we have the UDP, which is the user datagram protocol. So TCP is connection oriented and provide reliable and ordered data delivery, while UDP is connectionless and delivers data without guarantee, order or reliability. So there are basically two ways by which a port operates, two ways by which things are transported in a port. You either have your TCP, which is connection oriented, provide reliability and follows a sequential order when it comes to transferring data. But you have your UDP, which is connectionless and delivers data without guarantee of it being delivered or it following an orderly manner, right? So we're going to dive deeper into these two things. So the next one is well-known ports. So ports from 0 to 1023 are considered as well-known ports. They are they are assigned to commonly used services such as HTTP, FTP, SSH. These ports are standardized to ensure consistency across network. So well-known ports, think of it this way. So there are ports that are, as the name implies, well known, right? So they are commonly used ports, right? And there's this thing called commonly used services, commonly used protocols like HTTP. Everybody wants to access the web, right? There is FTP, which is the file transfer protocol. You want to transfer something from one device to another. That is file transfer protocol in action. Then there's SSH for secured shell, secured connection. So what happens is that from 0 to 1023 are assigned commonly used protocols, you understand, to ensure standardization across the internet. You get, so that everybody is not confused. Everything is standard. Everything has a standard rather. Then we have registered ports from 1024 to 49151 are considered registered ports. They can be used by software application, but registration with the Internet Assigned Number Authority is recommended to avoid conflict. Alright, so registered ports simply mean that this from 1024 to 19151 are ports that any software application can make use of, but they have to have registered it with IANA, which is an authoritative body, to avoid conflict. So basically these are like services that you want to make use of this port, but to avoid conflict when it comes to communication. Remember that I said that ports are like channels and doors by which communication happen, data enter and leave, right? Let's say for example you are trying to send things to the web server and somebody else is trying to send files through that same port. It can cause conflict. Do you understand? So basically that is why it has to be registered. Do you get? Then the last one is dynamic or private ports. Ports from 49 to 65535 are known as dynamic or private ports. They are available to be used by any application without registration. So ephemeral ports, they can be used by any organization. You don't have to register it. You can just make use of it. So why the understanding of ports and why is it crucial to cyber security? So number one, firewall use port numbers to filter and control network traffic. They can block or allow traffic based on the source and destination ports, helping to protect a network from unauthorized access and threats. So basically Ports are very important in the sense that when you are doing filtering on your firewall, right, you need sometimes you need to know the ports that you are working with. So on the internet, right, there are ports that are really kind of susceptible. There are some unsecured ports basically. So most organization administrator would block those ports or would limit those ports, access to those ports that are unsecured. Do you get it? This will help to protect network from unauthorized access and threats. Then we have port scanning. Cybersecurity professionals use port scanning tools to check for open ports on system. Unauthorized open ports can be po security vulnerability that needs to be addressed. So port scanning, so you can use things like Nmap to scan the ports of a particular host, that's a particular laptop, a particular network, right? So when you are doing host, when you are scanning the ports, you are looking for open ports. So unauthorized ports that are opened can lead to security vulnerabilities, you understand? So that is why learning about ports are very important, because you need to know the services that can happen on each port. You get it? So that way you can be able to tell that okay, if this one is open, this one is high danger. If this one is open, that is okay. You understand? Then intrusion detection. Intrusion detection system (IDS) and intrusion prevention system monitor traffic including port activity to detect and respond to suspicious or malicious activities. Then we have network service and vulnerability. Understanding services Understanding which service run on specific ports is crucial for identifying po ten tial vulnerability. We talked about this, how you need to know which service is running on which port, you get. So when you know what service is running on what port, you can be able to identify that okay, this is po ten tial vulnerability, and then the vulnerabilities of well known ports are well documented and targeted by attackers. So on the internet you can see information about well known port, like let's say port 80, port 443, port between 0 to 1023, the vulnerabilities that have to do with these well-known ports, right? So a lot of attackers will just look through the documents and then plan or obfuscate an attack. Then we have secure configuration. Properly configuring ports and services is crucial for security. Unnecessarily open port or misconfigured service can expose system to an attacker. So you need to understand port because you need to know how to configure ports and services when you are doing your network configuration as a cybersecurity engineer or as a cybersecurity personnel. So examples of well-known ports, we have port 80, which is HTTP, which is Hypertext Transfer Protocol, that's web traffic. Then we have port 443, which is HTTPS, which is basically Hypertext Transfer Protocol secured. That means the web traffic is encrypted. So we have port 25, which is SMTP, which is for sending mail. We have port 22 SSH, which is to secure remote access. We have port 21, which is file transfer protocol for transferring files. Then we have DNS, that's port 53, which is for translating domain name into IP addresses. Therefore, the examples of registered ports, we have port 3306, which is used by SQL database server. We have port 5432, which is used by Progress SQL, and we have port 1521, which is used by database Oracle database. So basically these are like database servers, right? The ports that database servers make use of. So these ones are registered. They register themselves under IANA. I hope this is clear enough. So let's go to the last part of the classes today, which is network protocol. Alright, let's dive in. A network protocol is a set of rules that governs how data is transmitted over a network. Network protocol defines the format of the data, how the data is packaged, and how data should be routed to its destination. So what are network protocols? They are rules that govern how data is transmitted over the internet. Simple, right? So what is the point of this thing? It serves as common language for devices to communicate. So irrespective of the software that is being made, that they are using, the programming language that was used to create it, the hardware, the internal processes, irrespective of anything, right? Network protocols are standard. So it's more of like a common language, right? That devices use to communicate with one another, basically. So what are the types of network protocols? We have the network communication protocol, the network security protocol, and the network management protocol. So let's dive in. Network communication protocols. Network communication protocols refer to the set of rules and convention that govern how data is transmitted, received, and processed across a network. So let's go again. It determines how data is transmitted, received, and processed across a network rather. These protocols play a crucial role in ensuring that devices can communicate effectively with each other. So network communication protocol, as the name implies, it deals with data transmission, how data is processed across the internet. Then the security protocols are crucial component of ensuring that confidentiality, integrity, and authenticity of data transmitted over the internet. So the goal is to prevent data from unauthorized access, from tampering, and from eavesdropping, basically. So security protocol, as the name implies, they are standing on guard. The goal of this protocol is to ensure the confidentiality, integrity, and authenticity of the data that is being transferred over the internet. You get? It's to prevent things like tampering, unauthorized access, eavesdropping, and so on and so forth. Then the next protocol we have is network management protocol, which are essential for monitoring, controlling, and maintaining network devices and services. They facilitate tasks like performance monitoring, fault detection, configuration management, and so much more. So let's dive in. So we have these are some of the examples of network protocol. These are some of the examples of network communication protocol and with some of their explanation. But you can do more research about it and dive deeper into network protocol. Understanding network protocol is very important, especially when it comes to networking and monitoring and analysis, cybersecurity analysis and stuff like that. This will come in very handy. Understanding IP addresses, understanding ports, and understanding network protocol. These things are very important when it comes to cybersecurity analysis. You get? It's basically the foundation. Alright, so let's dive into TCP. So TCP is Transmission Control Protocol. And what is the function of TCP? TCP is a connection-oriented protocol that ensures reliable data transmission between two devices on a network. So it is a connection-oriented protocol and ensure reliable data transmission. So the transmission is reliable. So how does it work? When data is sent over a TCP connection, it is divided into small packets. Each packet is assigned a sequence number. The recipient acknowledges the receipt of each packet and requests retransmission of any missing or corrupted packets. This process guarantees that the ordered and reliable delivery of data. So how does it work? So when you want to transfer something with a TCP connection, when you transfer data with a TCP connection, it breaks that data into smaller packets, right? And each of those packets is assigned a sequential number. So let's say you want to transfer something 1 through 1 through 10, 1 to 10, right? Each of the smaller packets is assigned a sequence number 1 to 10. So as the recipient, the receiving device, it will count it. So when you enter, so this is um data packet 1, data packet 2, data packet 3. If data packet 4 is missing, it can request that the source address or the source device should resend data packet 4, because that's the packet that is missing. You understand? Or that's the packet that is corrupted. So this would help to ensure that all the data that needs to be transferred are transferred, that there's nothing missing, right? So use case, TCP is commonly used for applications that require data integrity and reliability, such as a web browser, email, file transfer. You understand? So TCP is basically used for things like file transfer, email, web browsing. Talk about file transfer. One of the file transfer protocol we have is FTP, email is SMTP, web browsing we have HTTPS and HTTP. Excuse me, excuse me. So the next one we have is UDP. So UDP is user datagram protocol. UDP is a connectionless protocol designed for fast and efficient data transmission. So why TCP is reliable data transmission, UDP ensures fast and efficient data transmission. How does it work? Data sent via UDP is data sent via UDP is packaged into data graphs, and each data graph is sent independently. UDP does not guarantee the order of delivery or provide reliability metrics. There is no acknowledgement mechanism for received data. So basically for UDP, there's no way to acknowledge that, oh, I don't get this data, I don't get this data, oh, right? Again, but it's fast, right? So real time example is online gaming and video streaming. So when you are streaming on YouTube sometimes, you see that sometimes something will blow when the network is not that stable, but after a while it becomes clearer. You get, so that is UDP in action. Then we have IP. So IP is Internet Protocol. Function. IP is responsible for addressing and routing data packets within a network or the internet. So then you talked about IP addresses. So the protocol that is responsible for assigning an IP address to each device connected to the internet is called the Internet Protocol. That is IP. Alright. So router use these addresses to determine where to send the data packets to and to reach their intended destination, basically. So the protocol that handles assigning IP addresses to a device once connected to a network is the IP protocol, is the Internet Protocol rather. So the use case. So IP is the backbone of the internet and allows data to traverse network to reach its destination. So with IP address, even though we are not connected on the same network, we are connected to the internet, we can still be able to communicate with one another. You get. Then the next communication protocol we have is HTTP, which is known as Hypertext Transfer Protocol. HTTP is used for transferring web pages and other resources over the internet. How does it work? A client usually usually a web browser rather sends an HTTP request to the web server, which processes the request and sends back an HTTP response containing the requested resource. It uses TCP for communication. So we're talking about HTTP. HTTP is basically the web service, like the web traffic protocol. So how does it work? On your web browser now, you can query or request a web server. Maybe you are requesting Google Web Server. So HTTP, what do you call it? With HTTP, right? You can be able to request a web server, let's say Google Web Server, and the web server in question can respond to you, can send a HTTP response. So that's why when you type google.com, all of a sudden you are going to see Google page. You're going to see the Google page where you can ask the question you want to ask. Yes, excuse me. So we have use cases. HTTP is the basic of web browsing and allows users to access websites, view web pages, and download content. So being able to download things from the internet as well is HTTP protocol. So we have the SMTP protocol. That is the simple mail transfer protocol. SMTP is used for sending and receiving email messages, right? How does it work? When you send an email, your email client uses SMTP to transmit the email to the recipient email server. The recipient email server uses SMTP to receive and store the message. So basically SMTP handles sending and receiving email. So that is the fundamental for email communication, right? That's the fundamental for email communication. Then we have the DNS. The DNS is domain name system. So how does it function? DNS is used for translating human readable domain like www.example.com into IP addresses that the computer use to identify and locate each other on the network. We talked about IP addresses and how people can be able to communicate with one another or devices can communicate with one another using IP addresses, right? But think about it. You cannot cram all the IP addresses in this world again. So if you want to communicate with a web server, yes, the web server has its IP address, but there is something called a domain name system. For example, when you want to search on google.com, how the server knows that you are talking to it is not because the server has a google.com name, no, and because DNS handles the resolving. So DNS can resolve um the readable name like google.com to the IP address of the web server so that it will know that okay you are talking to me, you understand. How does it work? When you enter a web address in your browser, your computer queries a DNS server for the responding IP address. The DNS server searches its record or contact other DNS server to find the IP address associated with the domain name. The IP address is then returned to your computer, allowing it to connect to the requested website. So let's say for example you search for google.com on your web browser. Now, what will your web browser do? Your computer will query a DNS server that okay I have this domain name called google.com. Who knows the IP address of this domain name? So basically if your DNS server, if the DNS server you ask does not know it, it will ask other DNS servers that we want to connect, we want to go to google.com but we need to find the IP address. You understand? So when it finds the IP address, it will now return it back to your computer and your computer can now be able to speak to the web server directly. So how does use cases? DNS ensures you can use easy to remember domain names instead of complex IP addresses to access websites and resources on the internet basically. So without the DNS you will have to be cramming and learning a lot of IP addresses. So let's go into security protocols. So security protocols, we have the SSL/TLS, which is the secured socket layer and the transport layer security. So SSL plus CLS are encryption and security protocol for securing data transmission over the internet. How does it work? They encrypt data between a client, which is a web browser, and a server, which is a website. They ensure the confidentiality and integrity of data by encrypting it through transmission. So basically what SSL and TLS does is that when you want to transfer data from a client, that is your web browser, to a website, that data, if you are transferring it through the SSL and the TLS protocol, that data will be encrypted. You get? So this is to ensure that confidentiality and integrity of the data by encrypting it during transmission. It involves mutual authentication on both the client side and the server side. So what use cases can it be used for? It's used for to secure sensitive information like login credentials, credit bank information during online transactions. So mobile applications usually make use of SSL/TSL protocol. Then we have the IPsec, which is the Internet Protocol Security. So Internet Protocol Security provides network security, including encryption and authentication for IP traffic. How it works: IPsec is used to ensure communication between network devices, such things like routers, firewall, by encrypting data packet and ensuring their authenticity and integrity. So IPsec is employed in the VPN, that's virtual private network, and site-to-site connection to safeguard data as it transfers on what untrusted network like the internet. So basically the IPsec protects those encryption and authentication as traffic move across different IP addresses on the internet. So you need to really you can research more or dive deeper into these things. This is just the basic explanation, but I will employ you to go more and research and understanding the core of how these things works. You understand? So I have the SSH and the Kerberos. SSH is secured remote access control used to for secure command execution and file transfer. How it works: SSH encrypts the communication between a client and a server, ensuring confidentiality and integrity of the data. It provides user authentication to ensure um secure access. So basically what it does is that it provides a secure communication, right? A secure communication between a client and a server. So it encrypts the communication to ensure confidentiality. This can be used when you want to do remote access. No, we're talking about working remotely and the rest. So when you want to do remote access, things like secure remote administration, um for what do you call this thing, for remote login, for command execution, especially when you are a developer and you are doing SSH, you are SSHing into a server, right? You have to, so SSH can ensure that you are doing this over a secured connection, you understand, and then file transfer and the rest. So Kerberos is a network authentication protocol used for secure user authentication. So what do Kerberos basically is used for user authentication, a secure user authentication. Then we go over to Radius. So Radius is used for authentication, authorization, and accounting protocol used for um network access control. So how does it work? Radius verifies user credentials and authorize network access. It also logs user activities for accounting purposes. You get, so you need to dive more about this we need to dive more about this protocol, like understand the intricate details. How does it work? Examples of this, because these are the things that you would see when you are monitoring, when you are looking through a customer's environment, when you are looking through your network. You understand that things you will see, right? Okay, when somebody authenticate, which protocol handled this authentication? Was it Kerberos? Was it Radius? You understand? When someone is trying to connect remotely, was it SSH? Or the person use OpenVPN? Stuff like that, very very important things. So we have OpenVPN. OpenVPN is an open source VPN protocol that that provides secure encrypted connections. OpenVPN creates secure tunnels over unwanted networks, allowing users to access private networks securely, basically. So OpenVPN, like the way VPN is, no VPN is virtual private network, right? But OpenVPN provides a secure tunnel over untrusted networks. Then we have the management protocols. So an example of management protocol, we have the system SNMP, which is the system network Management Protocol. This is in charge of monitoring and managing network devices and their performance, right? So SNMP enables network administrators to collect data from network devices like routers and switches. These devices have SNMP agents that can be queried for status and performance information. So basically, this SNMP protocol helps with diagnosing and doing network health check, right? So we can use it to gauge the health of the devices you get. So we have ICMP. So ICMP is known as Internet Control Message Protocol. So ICMP is a set of network layer protocol used for network diagnosis and errors. So how does it work? ICMP includes various messages such as ping requests, error messages used for testing network connectivity and troubleshooting. For example, now if you want to connect to a particular host or to a particular IP address, you can ping that IP address and to see whether the connection works. If the connection works, then that okay, we can be able to actually connect to this IP address you get. So I think I'll probably do like a pinging example when we are done. So the next one is the use case. ICMP is vital for network testing and diagnosis and providing essential tool um for verifying network connectivity and pinpointing where the problem is. So when you are trying to solve like a networking problem, maybe you are trying to connect to a particular server and it's not working, you can use ICMP to detect okay where is this problem coming from, you understand. So that is why it's part of the management protocol. Then we have the syslog. So syslog used for is a protocol for collecting and socializing log messages from various networks. So devices such as routers, switches, servers, they all generate log messages. You understand? So logs are basically the happenings, like the happenings, what is happening on these devices. So how do you collect these logs? Use something called the syslog. Use something called syslog, right? The syslog server collects and stores these messages for analysis, monitoring and troubleshooting basically. Excuse me, excuse me please. Alright, so excuse me please. Alright, so let's go to NetFlow as well. So NetFlow is a protocol used to monitor, analyze network traffic flow data. So the NetFlow enables devices NetFlow-enabled devices collect and export data on network traffic, including the source, destination, and volume information. So basically, what NetFlow does is that it allows, excuse me, it allows monitoring and analysis of network flow. You get it allows monitoring and analysis of network flow in a network. So that's basically what NetFlow is used for. Then we have something called Windows Management Instrumentation. So this is a Windows-based protocol that allows management and monitoring of Windows-based systems. You get so the WMI, right, provides a standardized way to access information and settings on the Windows devices. So it's used for system management, inventory, remote administration. Then we have another protocol called the command line interface. So the command line interface, the CLI, is an interface for interacting with network devices and server through text-based command. So there's something called GUI and then there's the CLI. So CLI is basically just using your command line to do some things, to access network configurations, to manage the network devices and all of that. So CLI is essential for configuring and troubleshooting network devices and servers and offering a powerful and efficient way of controlling and managing network resources. So the networks, protocols that we just looked at. There are a lot of network protocol. What I just brought out are just the few ones that are very popular, that are most used ones, but there are a ton of different networking protocol. So I implore you to go and research about these things. Let me see. Okay, these are the discussion. Let me quickly let me Google IP address. Google IP address to ping. So let's ping 883. So let me open my command line. Let me open my command line and just show you an example of pinging. So if I come here and I do ping 8.8.8.8, so this is an example of pinging. So what pinging does is that it tries to reach this particular IP address with some sort of data, right? So it's pinging with 32 bytes of data. So it tried to reach it and say, okay, the time it took me to reach this thing was 51 minutes with 4 milliseconds. The time it took me to reach this again was 31 milliseconds, 23 milliseconds, and it now gives you a summary, sets ping statistics for 88.8.8. We sent 4 package and they received 4 package and we lost 0%. You understand? So for example, you are trying to ping something now that is not reachable, right? You probably get, oh, pinged 4, lost, and received 0, lost 100%. Let me see if this will work. Yeah, exactly. I don't know what this IP address resolves to. I have no idea what IP address resolves. I'm just showing you that if, for example, you are pinging an IP address that you cannot reach, you understand? This is what to show you. Time request timeout, and then it's going to explain sent for, receive 0, for lost for, which is 100% loss. You get? So this is just the difference. So this is how you use what they call this thing. This is how you use pinging, right? To be able to diagnose, right? To be able to diagnose or to be able to troubleshoot where the problem is coming from. You get? This is where you do it, where the problem is coming from. So this is how you figure it out, basically. So this is what a lot of people, a lot of network guys use, especially when you're trying to just troubleshoot. You're not sure where the problem is coming from again. So you just try and ping it. Once you see that the pinging is not working, you just like, probably it's a connection issue. You get? So think. Alright, so let's do our discussion. What is an IP address and how does it work? So we've talked about this before. What's an IP address? What is exactly an IP address? How does it work? Remember we talked about private and public IP addresses, right? Then how can IP addresses be used to block malicious traffic? You get? How do you think that with an IP addresses you can block malicious traffic from entering into your own network? Then can you identify some well-known ports and the services associated with them? Right? And can you identify common network protocols? I hope this helps, right? If you have any questions, please don't forget to send your questions here. Then this is the assignment. So number one, explore how the DNS, that's the domain name resolving system, works and why it is crucial to the internet. And what are the common cyber attacks that exploit IP addresses, ports, and network protocol. Alright, so drop your assignment here. Thank you very much for the class. Also note that you can get more information on YouTube. There are a lot of information on YouTube. Please get more information on YouTube. Dive deeper, understand the core concepts, because this is going to be very crucial and important when you are monitoring or when you get into the cybersecurity field. Thank you very much and have a wonderful day. Bye.